Good afternoon, everybody. Welcome to the Cinder-ceph integration with oVirt deep dive session. I am All. I will be presenting this deep dive. In this session, I will describe different features which we implemented for oVirt to support with Cinder and Ceph. And I will describe the flow of some of them and discuss some of them. If you have any questions, please share them in the oVirt channel. I will be monitoring them. Well, maybe at the end of the presentation, and you can use the chat also. So let's begin. So before diving into the integration, I want to spend a few minutes describing the external components which we used in this integration. We mainly use Cinder, Ceph, Urea, and Cocoa. So in a nutshell, Cinder is the block service for OpenStack. It is the open source project to develop OpenStack block storage. Without requiring any knowledge of where their storage is actually deployed or on what type of device they are. It mainly virtualizes pools of block storage devices, and it provides end users with a self-service API to request and consume resources. Among other things, it also orchestrates pluggable storage drivers such as Ceph, EMC, NetApp, and more. Ceph is basically one of the most popular storage backends for Cinder OpenStack. So regarding Ceph, a little bit of history about Ceph. Ceph started at 2004 as an open source project by Sagewell as part of the Inktank Storage Incorporation. And in 2014, Reddit acquired Inktank. Ceph is basically a software-defined storage, which means that among other features, Ceph provides it is basically storage virtualization, which provides a way to manage policy-based provisioning and management of data storage independent of hardware. Ceph provides also massive scalable distributed storage system and supports up to 10,000 servers and data capacity up to the exabyte level. Ceph also supports different type of storage types such as object, block, and file, although in its core it is managed mainly by object file system. For conclusion, Ceph provides a solid, resilient, highly extensible, and scalable storage solution. Another utility that we used is the Urea. Urea is basically an open source project written with Java. It is already used by oVirt Engine as a library to provide an easy communication with Keystone, Quantum, and Glance using the REST Easy connector. Urea was used in this integration to communicate with Cinder's REST API, and you can check the link of the GitHub. It is mainly the last one for the code and how it's written. This is example is the supported action that oVirt supports today using the Urea. So you can see here that regarding volumes, we can create volume, delete volume, extend volume, initialize connection, which is basically getting the basic data of the connection for a disk or for volume to be used for the VM to communicate with this disk. Regarding snapshots, we also have a create, delete. We can get a list of snapshots. Regarding volume types, and we have a list of volume types. We can take the list of the volume types. And regarding limits, this is basically regarding to the quota, which defined and configured inside the Cinder. The last thing that we basically used in this integration is Coco. As part of the Cinder integration with oVirt, we also integrated all the Cinder calls with a framework introduced only recently, which called Coco. Until now, we had the async task mechanism in oVirt that was basically dependent on tasks which were executed on VDSM. And now that we are using Cinder, we actually don't have these tasks anymore. So we are using the Coco infrastructure to manage this, manage those tasks through Cinder. So Coco is a framework which supports managing of asynchronous actions such as storage actions. And this framework manages and persists those commands by specific logic based on parent and child callback commands. Eventually, this is how it works. This is the basic flow. We have the oVirt engine, which communicates with Cinder through the OpenStack Java SDK, which Uria provides. Cinder add, delete, update, all the disk snapshot in Ceph are being used through Cinder. And oVirt is actually using Coco to sample Cinder and know if the task has been ended or not. Now I want to show you how we can add a Cinder provider. So I'm going to show you a small video which provides it. One second. Okay. So this is an example of how we can add Cinder as a provider. As you can see, we are using the Cinder host. We can see here the tenant name, which is admin. And now we are going to external provider. We're going to add a new provider, give it the name and the description. We choose the type. We should choose the type of volume, OpenStack volume. Which data center do you want it to be used? And we provide the URL, which is the Cinder host. Here we use the username and the password and the tenant name that we saw before, which is the admin. This is the authentication URL, which is basically the keystone. We test it, see that it succeeded. And now we have a new Cinder provider. You can see it actually, which is part of the data center. You can see this is mainly storage domain, used as a storage domain here. And we can see it here also. Okay, back to the presentation. So once we added the Cinder provider, we can now use it to add new disks. There can be actually more than one backends per volume type. And the cinder-conf is the file that which being written at the Cinder volume startup. Backend is basically Cinder volume backends are spawned as children to Cinder volume, and each backend is used for storing virtual machine images. The volume types actually provides a way to define one or more backends, which each one reflects type of storage cinder. As I said before, the configuration is a cinder configuration, which is under etc cinder. And currently, oVirt supports one backend per volume type. Now I'm going to show you how we add a new cinder. One second. We add a cinder disk. So here we're going to add new disk. We're trying to add a cinder disk, and then we see that the volume type is actually empty. What we need to do here is that we need to actually add the new cinder, the new Ceph backend. So you can see here at the bottom of the screen that we outmarking the Ceph backend. You can see here that it contains volume driver, volume backend name, which is Ceph. Then we need to enable this backend in this Ceph properties. As you can see here. The volume backend name is very crucial for us, for Cinder to know which backend to use at a defining process. We will see it in a few seconds. So after this was defined, we're now going to the OpenStack GUI. We create a new volume, which is called Ceph. And you see here the volume type extra spaces. Here we actually provide the volume backend name, which is Ceph. After we will refresh this, refresh the screen, we can see that there is a new volume type, which is called Ceph, with this extra specs. And after that, we will want to do restart for the OpenStack single volume service. And we can see here now that when we want to add a disk, we see volume type Ceph. So this is basically it. Okay, back to the presentation. So we basically saw how all those components get together, but still we haven't referred to one thing, the VDSM component. VDSM is not familiar with Cinder OpenStack since it is mainly managed by the engine, although VDSM should be familiar with Ceph since it acts as a hypervisor for running VMs, which might have Ceph disks. So to communicate with those disks, VDSM uses librd. librd is a library which provides a file-like access to RBD images. It is used by oVirt and qemu to use Ceph block devices via librd. Ceph, yeah. Okay, regarding secrets, Ceph authentication provides a way to manage permissions for users to view information from volumes. Cephx, it's actually supported by Ceph, and it used for secure authentication between the nodes within the cluster. So each connection and communication are initiated with this authentication mechanism. It is based on Kerberos ticket trust mechanism. Secrets are registered automatically through oVirt upon every host activation or storage domain activation through all the hosts. So this is how the registers go. We have the OpenStack and Ceph, which are Cinder communicate with this Ceph storage. Through Ceph, we are generating an authentication key, which is some kind of string. This key we are using oVirt with this key, and oVirt generate also a UUID, which also a user can change. And this GUID is actually the one that we will be passing when we will try to run a VM or to the host. This GUID, which oVirt provides, we are updating the cinder-conf with this GUID in the Ceph backend. oVirt save this GUID also in the database, and it uses register leave secret, which is a new API for VDSM to actually save the secret key with the UUID and the Cinder storage ID. These all are maintained in the libvirt. I'm going to show you another video how it actually being done. Okay, so when we try to run a VM, before we generate the secret, we can see that the VM failed to start because there is a problem with the secret UUID. What you want to do is you want to get into the Cinder and create this GUID of the authentication key. Here in the oVirt, we are going to the external provider, go to the subtab of authentication keys and add a new key. We use this key that we generated through Ceph to the authentication key and use the UUID, which oVirt provide us, to actually change it in cinder-conf. So here is the backend, the volume type that we used before. We are using the secret to UUID that we used before in the libvirt as a user. Now we have the authentication key generated, and now the hosts are being updated with this key, and we try to run the VM. Okay, we do a restart. Yeah. Run the VM. And you can see now that the VM is actually starting. Okay, so back to the presentation. So how actually we run this VM? How it works under the hood? So what actually is being done that oVirt every time that it wants to run a VM, it requests from the URIA, which requests from the Cinder, the connection info. The connection info is actually data that we want to use, so the qemu or the VM which runs the VM with this Cinder disk can communicate with them, can write to them, and can read from them. So we're getting the connection info, and then from this connection info, for example, we are generating the Ceph UUID and username and the auth, all the auth keys, among other data that needed to be used. VDSM passed them to libvirt, again with the secret type and the UUID. And libvirt actually uses KVM and qemu to talk to librbd, which will talk to the Ceph Cinder, to the Ceph volumes. Okay, so after we saw how secrets work, let's talk a bit about snapshots. So Cinder supports volumes, and it also supports volume snapshots. Cinder disk, this is the main problem that we also have a bug on Cinder on that. So Cinder disk cannot be deleted if it contains snapshots, and I will show you in a few slides why it makes the deletion of disk a bit problematic for oVirt. Also, Cinder volumes and snapshots are reflected as an independent entities, and I will, again, in the next slides, I'm going to show you why I'm referring to them as independent entities. So until now, we have an image volume, which was actually inside of oVirt using VDSM. This volume was basically a volume that was used by the VM. When we created the snapshot, then we actually added the new volume through VDSM, and we told the VM, this is the new volume that you should be written on. And the last volume was, the previous volume becomes the snapshot. It becomes read-only. And as we create new and new snapshots, every time the active volume is updated with the last one, the last volume that was created. In Cinder, it works a bit differently. If you are using Cinder, we actually creating a new volume. And this volume, this VM knows it and writes data to it and read that data from it. And when we create a snapshot, it's actually being defined or being referenced as a new entity. This is what I talked before. It is referenced as a volume snapshot. The volume ID that we are using through Cinder is actually stays the same. Every time it stays the same. What's done under there, under Cinder and Ceph, actually reflected to oVirt as one entity of disks that is always being used. So when we create, again, more and more snapshots, we are still using the same volume to write and read data from. So regarding preview of snapshots, when we are previewing an image, what's actually done is that we're creating a new volume, which is the active volume right now, and it's based on snapshot 2, for example. And the active volume is becoming some kind of preview state, which it's waiting if you want to commit it or not, or just undo it. In Cinder, it works a bit differently. So as you can see here, this is how the volumes look at Cinder. We have 3 volume snapshots, and we have one active volume here, one volume. When we preview a Cinder snapshot, then we have actually 2 volumes and 3 snapshots. And once we commit it, we're actually being left with 2 volumes and 1 snapshot. Okay, we need, the main problem is that we can't actually delete the original volume because it has a snapshot, and we want to save this snapshot because maybe in a later time we want to preview this snapshot again. So after we commit it, if in the image we're being left with 2 volumes, in Cinder we're being left with 3 volumes, with 2 volumes and 1 volume snapshot. And the last one is the active one that we are trying to use. So if you create, for example, another snapshot, this snapshot will be upon the active snapshot, the active last snapshot. Okay, so in Cinder we will have 2 volume snapshots and 2 volumes, and we can see that the last volume snapshot is based actually on the active one, and we have the first snapshot, the initial snapshot, which is based on the original volume, the first volume that we created. One more thing regarding snapshots, it's live snapshot. So regarding live remove, when you're using Cinder, there is no merge, which we done until now with volumes. Until now, which we are oVirt, when we were using volumes for VDSM, we're using qemu, and we actually implemented this architecture in the oVirt. So when we tried to remove some snapshot, we actually did some kind of merge, and that made us a bit difficult in the live merge. So in Cinder, it's more simple, since the snapshot is actually reflected to us as some kind of independent entity. We can remove this snapshot, and it will be transparent for the VM. I mean, the VM will keep using this the active volume, and it doesn't makes oVirt to use extra logic. Regarding live Cinder snapshot, this is a bit of a problem. What we introduced in VDSM, which is new, are 2 major APIs, two APIs, freeze and tau. Until now, freeze and tau were implemented as part of the libvirt snapshot, and it was implemented inside libvirt. Today, libvirt exposed those capability of freeze and tau, and now we can use them independently. So what we are doing today is that when we create a snapshot, a live snapshot on a running VM, we are actually using this freeze to create a new Cinder snapshot without any data corruption or data inconsistency. And when we are finishing creating this snapshot, we are using tau to also release the VM from this freeze and keep working. So what happened when trying to delete this Cinder disk that we showed before? So if you try to delete it, we actually getting some kind of error for deleting the original volume. This is why because we can delete volumes which has snapshots which are based on them. What we need to do is we need first to delete the snapshots and then to delete the volume, which is actually the one which all the snapshots are based on. So what we need to do is we need to start deleting it from the snapshot, and then just remove the next volume, and going again from the snapshot, and at the end just remove the last volume. So this is how delete disk being done to a Cinder disk. So today, Cinder supported action with oVirt are add disk, edit disk, delete, extend, attach, detach of Cinder disk. All those actions are supported through oVirt. We have read-only disk and share disk, which are also supported through Cinder and Ceph. We can create and remove a template and create VM from template, add Cinder snapshot as we saw before, also live, delete Cinder snapshot, also live, clone VM and template from VM or snapshot, create VM pool. There is also a stateless VM that we are supporting, and this is basically the features that we are using. I want to show you just last movie about the snapshots. One small video. 1 second. So this is an example of how we create a snapshot through Cinder. We are creating a Cinder snapshot on a VM, which has one disk. And as you can see, in the OpenStack Cinder, we will log into it. And we can see here at the volume snapshot, the new snapshot that were created. So this is just an example of creating a snapshot through Cinder and how it looks like. Back to the presentation. So what are future plans? Well, we want to also implement a DR solution, like using an oVirt store disk, so we can import the Ceph storage domain, and we can basically use it to restore VMs and templates which we had before disaster to restore them. We also planning to use monitoring on the Ceph storage. Currently, we are monitoring only if a host has a package of librbd, but we are not monitoring any I/O through Ceph. And move disk also between Ceph and traditional oVirt storage. This is the wiki links that you can use. This is a Cinder integration. It has many print screens and explanation about what is supported and how to do different operations through Cinder and Ceph. And this is basically it. It took me a bit less than 1 hour, but it leaves us maybe more time for questions. If you have any questions, then please use the oVirt channel, which is here through the IRC of TCNet. see if there are any questions. Okay, I don't see any questions. Okay, let's see if there is something in the chat, maybe. No. Okay, so thank you very much.